Hello everyone, my name is Loveness from University of Dar es Salaam, campus of Mkwa, University College of Education. I'm taking Bachelor of Science in Education, specialized in mathematics. So I would like to welcome my friends to introduce themselves.
My name is Emmanuel. I'm taking mathematics and economics.
My name is Meshack Butambara. I'm taking mathematics and economics.
Okay, our project is based on the Cauchy-Goursat theorem. So now we are going to state the Cauchy-Goursat theorem and how it is applied in real life. So the Cauchy-Goursat theorem states that if a function is analytic everywhere, inside and outside the closed curve, then the integral along the closed curve is 0. So the mathematical formula of a theorem is integral under closed curve of f of z dz equal to 0. Key ideas to understand from the theorem is analytical function and closed contour. For analytical function, a function to be analytic should be differentiable and should satisfy Cauchy-Riemann equation. And for closed contour is any closed path. Examples: square, triangles, and circles. Okay, so let us move to the application of Cauchy-Goursat theorem in real life, which is heat transfer based on heated water. Let's look on the ET's demonstration. Here we have heat source, pan, heated water, and a metal ring. So, a metal ring placed inside heated water represents a closed curve. The ring itself does not produce heat. It only acts as a boundary that separates the inside region from the outside region of the metal ring. When the water is heated uniformly and there is no heat source inside the ring, heat flows smoothly through the water. According to the principle of conservation of energy, amount of heat entering the metal ring equal to the amount of heat leaving the metal ring. So, there is no net accumulation of energy inside the closed curve. This situation is analogous to the Cauchy-Goursat theorem, where the absence of singularities inside a closed contour, if a heat source were placed inside the ring, the balance would be disturbed, just as the presence of singularity inside a contour would make the integral non-zero. Therefore, this demonstration does not directly apply the Cauchy-Goursat theorem, but it helps us visualize its physical intuition using conservation of energy and smooth flow. From the demonstration, heat transfer formula, where a metal ring is placed in hot water, heat transfer from the water to the ring until they reach the same temperature. If we assume the container is perfectly insulated, no heat escape to the room, the formula for no accumulation or energy balance is heat gained plus heat loss equal to 0. Or, written more simply, heat gained by ring equal to heat lost by water. This tells us that every bit of energy lost by the hot water is gained by the metal ring. In our project of Cauchy-Goursat theorem in complex analysis, if a function of f of z is analytic, means smooth or no singularities inside a closed path, so integral under closed curve of f of z dz equal to 0. The logic: just as a heat source adds energy to the system and breaks the zero-sum balance, a singularity adds a value to the complex integral and prevents it from being 0. This is the end of our presentation. Thank you for listening our project. about Cauchy-Goursat theorem.